Hey class, based on scores I'm seeing in the Khan Academy, I wanted to record this real quickly and talk about one of the problems that I see some difficulty in. It's the section where Sal talks about dividing line segments. That's the topic. And the problems that they're presenting look something like this. This is kind of a typical one. And basically, at the heart of this, there's some hidden similar triangles. And if we think about these as similar triangles, it's pretty straightforward, but I just want you to make sure you understand the vocabulary and what's going on here. So it says that A, B, and C are collinear. This word collinear means that these 3 points must live on the same line. And furthermore, it tells me that B has to be between A and C. So if they tell me where point A is and point B is, right? If I'm told where A and B are, I can't say that C is on that line because then that would violate this thing that B has to be between A and C. So C couldn't be between A and B. So what has to happen is if I extend line AB somewhere else, right, on that same line because they're collinear, is going to land C. And what the question is what's the XY coordinates where that C has to be? So let's see if we can take a look at this. So the other thing that they tell me is that the ratio of AB to AC is 4 to 5. So I'm going to write this down as a ratio, right? And you can use either notation, but I'm going to say AB over AC. AB over AC. And I know based on just this one-dimensional diagram, if this is A and this is point B, and then somewhere later is point C, I know that AC is the longer segment, right? Of those, considering AB and BC, AC is the longest segment. So I can say that this is the larger segment, and this is the smaller segment. So I'm just talking about AB is the smaller segment, AC is the larger segment. And that ratio is equal to 4 to 5. 4 to 5. So the ratio of AB to AC is 4 to 5. Next. So it says if A is at the point negative 3, 7, and B is at the point 1, negative 5, what are the coordinates of C? So you can see on this diagram, I went ahead and sketched A at negative 3, 7, and I sketched B at 1, negative 5. And what we're trying to do is figure out somewhere down this diagram, if I keep sketching down, somewhere down here, we're going to hit point C. We don't know where that's at. Now, something that would be useful for us here, and this is something that happened with Sal in the academy, is he talks about this triangle, right? This triangle right here, the triangle that connects A and B, right, and forms this right triangle. So I can travel from A to B. I've got this horizontal line and this vertical line, and I have this triangle, and I know that this is a right triangle. And in fact, I know some things about this right triangle. I know if I look at these points, this is the point negative 3, comma 7, and down here, point B is at 1 comma negative 5, 1 negative 5. If I look at the x coordinates, I can see that x is going from negative 3 to 1. And if that distance, right, 1 minus negative 3 is 4 units. So the distance along this is 4 units. And similarly, the distance, if I look at I'll triple underline these, from 7, and here's negative 5. So if I travel from 7 down to negative 5, 7 minus negative 5 is 12 units long. So I've got this similar triangle, this triangle right here that has 4 and it has 12. Now if I scale that triangle up, and in fact let me bring this diagram over. I think I can move this around and talk at the same time. So this is a triangle that I've made, and it has the exact same angle A, and it has the exact same angle C. Right? But what I've done is I've made it larger. So this is a scaled up version. So I was able to scale this triangle up, and it's similar to the triangle that I have here. Now this is not the right triangle. This is not showing me where point C is. The point is I just want to talk about the fact that these similar triangles are going to allow me to answer some questions. So let's think about these similar triangles. So over here, On the small triangle, I've got a 4. And this piece, I'm going to label x because it's x units from A to over to where this right angle is, this small leg. And I'm going to do the same thing for this, for the vertical change. So going along here, this is y units long, right? So these triangles, right, have this exact same thing going on. In fact, let me see if I can grab that, bring this over here. Let me get rid of the C in that line segment and maybe make this a little bit larger because I think it deserves some attention here. So we've got this ratio that says smaller triangle to larger. It was smaller segment to larger segment, but because these are similar triangles, these ratios all have to be the same. So if I was going to go from the small AB to the larger one AC, that's 4 to 5. If I was going to go from the small triangle, so the ratio is all 4 to 5. If I was going to go from the smaller triangle where I've got a change in y of 12 to the larger triangle when that change in y is y, I don't know that value, right? This is beautiful because this allows me to figure out how big of a change y is. Just using the fact that they're similar triangles, I can solve this. I would say in this case that I'd like to multiply both sides by 5y and get rid of the fractions. So if I multiply each side of this equation by 5 times y, on the left-hand side, we end up getting just 4y. And on the right-hand side, when I multiply that, I end up getting the number 60. And if I divide both sides by 4, I see that y is the number 15. So this change, this value along y, is 15 units. So basically, I now know before I was going down 12, I need to go down 15 units, and I'm going to be on the line, right? I'm going to be on the line where point C is. How far over do I go to the right? Well, let's look at that's actually easier to answer because you can see on the small triangle over here it was a 4, and it's an x here, so I can write small triangle. Well, my ratio is 4/5. And then small triangle is 4, large triangle is x. So I don't need to solve anything, right? X is going to be 5. That's the only value that would make this true. If you feel like that's cheating somehow, you can. Another way you can solve these is because these truly are ratios that are forming a proportion. It is true that, and this is just fraction, but this is just me multiplying both sides by 5x. But when I do it, I end up getting 4x is the number 20. And looking at those cross products, which I hate even saying, but looking at that, I can see that it lands at 4. 4x is 20, x has to be 5. So I know that this change here along x, right, this has to equal 5 units. So these two are the important values. I'm going to go, I was going over 4, but now I actually need to go over 5. I was going down 12, but I actually need to go down 15 to figure out where C is. So let's just come back up here and do this. So you can see instead of going over just 4, I'm going to go over 1 additional unit, right? There I am, and I'm going to go down 5. Instead of just going down 12, this is me traveling down 12, I need to go down 15. So I'm going to go down 3 more units. I'm going to go down 1, 2, 3. So instead of landing at -5, when I go 3 more down, I end up landing at -8. So I now have identified the location of point C, right? C has to live at the point where x is 2 and y is -8. X is 2 and y is -8. Now, a nice kind of thing that an honor student would do would be like, hey, I bet if I found out the two hypotenuses, if I found the length AB and I found the length AC, I bet that ratio, if I was to do AB divided by AC, it would really be 4/5 because that's what we're saying, right? Remember, we're saying that length is 4. The ratio AB to AC is 4/5. Well, if I figured out, how long AB really is, and now that I know where point C is, I can figure out how long AC is, If I do 1 divided by the other, I'm going to get 4/5. So that's one of the problems. The other problem that he talked about looked something like this. In fact, this might have been one of his problems. But it says a circle centered at the point 3, -5 has a radius of 7 units. Is the point, and then he gives me some other point. And the question is, the point that he's giving me, is the point that he's giving me going to be outside the circle? Is it going to be on the circle? Or is it going to be somewhere inside the circle? Where is that point at in relationship to the circle? Is it outside, on, or in the circle? And it's not a particularly difficult question, right? Because they tell us the radius of the circle is 7. So if I know my circle's radius is 7 units, right, all I have to do is figure out the distance. Let's say that this is the point I was given. I just need to figure out the distance between the center of the circle and the point that I was given. And to figure out the distance between 2 points in the Cartesian coordinate plane ends up becoming, a Pythagorean theorem problem. But once I know that distance, I just look at it and say, hey, if that distance equals 7, then I was on the circle. If the distance is greater than 7, then I was outside the circle. And if the distance is less than 7, then I had to be inside the circle. So that's it. I just wanted to talk about those 2 problems. And good luck over the next couple days. And remember, on the post, I did say that even if you don't finish by Friday at 11:59, I will still consider your points and look at your work if you work on this next week as well. All right, guys, I hope to see you online soon. Thanks for those of you that are dropping in and asking questions. I like hearing from you and seeing how you're doing and trying to be helpful in some way. This is Mr. Roberts. I'll talk to you soon.